A few weeks ago, we recognized an engineering student named Jorge after his girlfriend Adriana told us how big a fan he is of the show. Hearing afterwards from Jorge about how much it meant to him was one of the more rewarding experiences I've shared with our listeners. Here's what he said. Words cannot begin to describe how grateful and appreciative I am of both you and Adriana for gifting me such a memorable and amazing moment. I still can't believe it. Well, Jorge, it was our pleasure. And it gave us an idea. Live today, we are introducing a new program to the Being an Engineer podcast to recognize engineers who excel in their field. We're calling it the Being an Engineer Circle of Excellence, and we hope it will be a way to more fully realize the mission of the podcast as a tool through which engineers learn about and connect with relevant people, resources, and opportunities. We also hope it will be a way for you, the listener, to experience the joy and excitement associated with recognizing worthy peers and being recognized by your peers. To submit a nomination, go to teampipeline.us/excellence and fill out the form with the name of your nominee and a short description of what makes him or her deserving of the award. We here at the podcast will review the submissions and select winners. Those winners will be announced and recognized on the show and will receive some complimentary Being an Engineer podcast swag. The program is live right now. Go to teampipeline.us/excellence and give a deserving engineer the gift of a memorable and amazing moment of their own.
That part's frustrating, but I think that makes that final moment at the end so much more rewarding when you finally do get it.
Hello and welcome to another episode of the Being an Engineer podcast. Today we are speaking with Russ Angold, who holds a bachelor's degree in engineering from Caltech and is the co-founder of Ethereal Matter, where we'll talk about later in more detail. Russ, thank you so much for joining us on the show today.
Oh, no problem. Happy to be here. I do have to make a correction, though. I didn't go to Caltech. I went to Cal Poly, California Polytechnic State University.
I'm
so it's
sorry.
a little different than
Thank you for correcting me. I had that written down and I totally messed up. That was my mistake. Thank you for the correction.
No problem.
Starting off to a great start here, aren't we? Jeez.
Yeah.
All right. Well, Russ, how did you decide to become an engineer?
I probably didn't actually know what an engineer was early on in life, but as a kid, I really enjoyed working with my grandfather. You know, he would build things. He was in the construction space. He was also a machinist, and a mechanic. And so just kind of a general tinker and doer of all things. And so I learned a lot from him as a young kid. And then I just always had this desire to understand how things work. So I'd take apart all my toys and figure out how they worked and then put them back together. And, I like to joke with people. I said the difference is after I got my engineering degree is now I can put them back together and there's typically no leftover parts.
Leftover screws, yeah. I know exactly what you mean. I was always that way as a kid as well. I didn't have a machinist for, in the family or anything like that, but I love to take apart toys and see how they work and try and put them back together, doorknobs, just anything mechanical, things like that. I think that's kind of I hate to say it can't be taught, but I think there are people who just innately have that desire or passion to understand how mechanical things work. Then I've come across other people, some of which are engineers as well, who they just, I don't know, they don't have that same like organic desire or curiosity about them. It's interesting how that happens. But
and I think there was that, and there was also like whenever there was chores to be done around the house, I was always trying to figure out a way to do it more efficiently. So it's like, oh wait, can we make something to make this like less labor intensive? And it was funny because I have 6 brothers. So like some of the brothers would get started and I would like go off and try to figure out a way to make it easier on us. And sometimes it would work out and sometimes they'd finish before I could figure out a way to make it easier. So, yeah, it was pretty funny.
That sounds to me like a process engineer right there. That's great.
Right.
That reminds me of when I think I was in second grade, and my teacher, I think she just wanted to keep me busy for a while. Maybe she didn't have something to do, hadn't prepared her lesson plan, or I don't know, something, but she gave me this stack of like 50 or 100 pieces of construction paper, like the purple and red and kind of thick construction paper used in elementary school. She says, I need you to fold all of these in half. And so I said, oh, okay, I'll do that. So she went away. And I was looking at this thing and thinking to myself, it's going to take forever to like pull each one of these apart and fold them all in half. So I just took the entire pile and I folded it in half. And I went back to her, here, it's done. She's like, no, that doesn't work. And anyway, I didn't get off the hook. I had to go back and take them all individually off. But I understand what you mean by like always trying to find ways to make things easier and faster.
Right. Always looking for that edge.
Right, yeah. Well, you co-founded a company called Exobionics, where you engineered solutions to, and I'll quote here, rethink current physical limitations and achieve the remarkable. Can you tell us a little bit about Exo and some of the ways that you helped people achieve the remarkable?
Yeah. So Exobionics was in the name, an exoskeleton company. The funny thing is that's not the first name the company had. When we started the company back in 2005, like the majority of the world did not know what an exoskeleton was. It wasn't until I think the Iron Man movie came out where people started to know what an exoskeleton was. So early on, we were called Berkeley Bionics, I guess, because people still remember the Bionic Man TV show. So what we were focused on there early on, the technology came out of a DARPA program. So for those that don't know, DARPA is the Defense Advanced Research Project Agency. So they fund far out stuff, right? So they were funding us to try to develop an exoskeletons for soldiers to remove and reduce the amount of injuries that they were seeing due to load carriers, because some of these soldiers carry a tremendous amount of weight. And they were seeing a lot of knee and back injuries. And so that's where I got started. That was a project at UC Berkeley, and I came in to work on that. One of my brothers, he had gone on to be a Navy SEAL, and we made a deal when we were kids. I said, you go be a Navy SEAL, I'll be an engineer, and someday, I'll make you cool stuff. And so
no way.
So when the opportunity
awesome.
when the opportunity came to work on the exoskeletons, I was like, oh my God, this is perfect, right? He's a SEAL. This is totally for him. So,
wow.
It was a dream come true. I literally quit my job without even showing my brother that I was currently working on, and came back up to the Bay Area to start working on the project. And, there was a couple interesting things that happened. One, I finally showed my brother the video, which he was like, wow, that thing is too slow. It's too loud. It's too heavy. We're never going to use it. So, kind of on the life lesson, if you're going to bet the farm on a technology, you should really understand what your customers are looking for in that space and make sure it aligns with what they're looking for. And the second thing that happened was my brother was actually in an accident and broke his neck. And so I remember getting a call from my mom. So we flew across the country to go see him in the hospital, thinking about how we could use this same exoskeleton technology to get him up and walking again, walk into his hospital room, saying, hey, brother, I'll get you up and walking again. I, sketched out some ideas. And it was interesting because I knew nothing about spinal cord injury at the time. And he was like, I can walk just fine. I just can't move my arms. So he had what's called central cord syndrome, where you damage the outside nerves in your spinal column, which affect it's like an upside down tree. So the outside up top affects your arms more than your legs. So the central cord was fine. So he could still walk, but he couldn't use his arms. But I'm happy to say he is, he was fortunate and has completely recovered and is doing great.
Wow,
Never needed an exo. But it took years of rehabilitation. And the takeaway for us was he was fortunate because it was his arm, so he could, continually do rehab with small tasks and work himself up to bigger and bigger tasks as he got stronger. But that's really hard to do if you lose the ability to walk, whether it's spinal cord injury or stroke. And so that's where we came in with medical exoskeletons, really seeing the value where you could provide someone that level of assistance where they could do walking rehab. And as the user got stronger, the exo could back off on its power, and eventually, they could walk out of it. And people are doing that now in the case of strokes. So, it's interesting how that all unfolded in a matter of weeks. But that's life.
Thank goodness he's okay. Incredible story. Thank you for sharing that. So when actually, let me back up just a little bit. I'm really curious, the DARPA funding, how does that work? Is that like a huge process that you have to go through that takes forever and you have to hire consultants to help you navigate the government bureaucracy, or was it, fairly straightforward?
It's definitely a competitive process. Any of the government grant funding process is competitive. We started, the initial winner of that grant was UC Berkeley and Professor Kazaruni. So Nate and I, they were the other co-founders of EXO. We were consultants to the lab trying to help make this prototype more commercial. So we were working side by side with PhD students trying to take these ideas that they had and the work they had done and try to turn it more into a commercial type product, right? Bringing stuff we knew from industry into the recipe, so to say. And so that we didn't have to. That was through UC Berkeley on that funding. Now, when we kind of went a separate path and went a much lower powered path for our exoskeleton designs. So the Bleaks, which was the exoskeleton we were working on at Berkeley, that thing used about 3 to 5 kilowatts of power, depending on how fast you were going. So a tremendous amount of power, right? So IC gas engine running on the back, running hydraulic pumps. And it was kind of crazy. It was amazing. It's the world's first untethered powered exoskeleton back in 2005, but also not a viable path going forward. So our next exoskeleton used, Exo Hiker used about 2 watts of power. And so that's when we went and showed that back to DARPA, but that didn't align with what DARPA wanted to do. DARPA wanted a big powered Ironman suit. So we actually got down selected. They said, okay, we're not interested in that path. If you guys are interested in that, you can go do it on your own, but that's not where we want to go. So they selected another company named Sarcos, which is still in the exoskeleton business today. They picked them to carry forward with them. And we actually we stopped getting the DARPA funding, but went after some other NSF, National Science Foundation funding, and some other things to go more towards the medical applications based on this new low-powered exoskeleton. But back to your question, yes, there's a lot of work. It's kind of weird to navigate some of the grant space. There are people out there that can help you. So if you're looking for that path, it's definitely a worthwhile path to really get some, hard technology out. It's essentially free money, right? You have to work for it and you have to provide results, but it's a great way to get an idea off the ground, especially if you're doing, kind of that foundational or early research where you're not really ready to take anybody else's outside funding. You're a little too early for commercial or venture funding. But that's the purpose of some of those organizations, is to try to fund those crazier ideas to see if there's a there, right? How do you get to that point where you think like, hey, this is a viable future? And that's what they're there for.
Yeah. It seems like you really have to commit for one of those grants. I mean, you could spend, correct me if I'm wrong, but months preparing for one and submitting it and then not be selected, right?
Yeah. I mean, I encourage anyone that is going to go down that path to try to connect with the PIs or whoever's in charge of that area of the granting organization. Like NSF has a workshop every year. The program managers or DARPA does, or whoever the granting organization typically has some open house event where you can go and meet some of these project managers. And I always encourage people before you get started in writing a grant and just, throwing it over the wall without kind of talking to anybody, at least email, have a phone call with somebody, tell them what the idea is, see if that fits with what they're looking to fund. Or go try to meet at one of these conventions or conferences where they're all getting together and they're talking about, the ideas they're looking for and the technologies they're looking for. Just go have an interaction with somebody, because at the end of the day, people work on relationships. And if you can have at least some sort of relationship and understand what that program manager is really looking for and how that fits with the technology you're providing, you'll have a much better chance of success in getting that grant across the line.
That's a great pro tip. You mentioned PIs earlier. What does that stand for?
Sorry, the PI is principal investigator. That's typically who's running the grant. And then on the grant side, you have the program managers, the PMs. So the PI is typically whoever is the lead on the company side that's going to be writing that grant.
Okay, got it. Great. Well, you are currently working at and the co-founder of a company called Ethereal Matter. Can you tell us a little bit about Ethereal Matter and how it will transform home fitness workouts? Yeah,
so I've known Scott Summit for, maybe 15 years, going on 15 years. We did some stuff together early on when I was still at Exo. And then when I stopped working at Exo, I saw some of the stuff he was doing, which this is all Scott's brainchild. I just came in to help with some of the engineering design. But he...
and Scott, sorry to interrupt you, Scott Summit is an industrial designer who we had on the show a few months back. Right.
So Scott... came up with this concept, which I think it's really cool, right? It's basically, how do you have a full on immersive physical experience in a VR environment? Not just put on the headset and walk around your room, but how do I climb stairs or, interact with physical objects and do all sorts of other things. And, the machines come a long way. I don't know if you've seen the latest machine, but the machines come a long way from the early days. And now the experience is pretty cool. I was in there the other day flying around a castle in the Ornithopter, right? Flying through, and like you forget that you're working out. So the whole concept is like, gaming's fun. I have 2 teenage boys. They love to game. But typically when they're gaming, they're sitting in their chairs and they're not getting a lot of exercise. So how do you make gaming so fun that people will want to be in there and getting exercise at the same time that they're gaming in this VR fitness machine, which, and it could be anything from just, actually getting exercise to escapism, like going paddleboarding through Tahoe or whatever, just taking a break from the real world. But it's pretty cool once you get inside of it and start moving around and feeling that feedback and really interacting. You kind of detaches you from the real world for that moment, and you're transported somewhere else, and you get to have a cool experience.
That's amazing. Is this going to be for retail sale, or would it be, like in a gym that you might have a membership to, or something like that?
Most likely it's going to start in gyms because it is a bigger piece of equipment. So starting in gyms, or we've talked about other locations like movie theaters or other things. I was thinking the other day, like it would have been a great partnership to like team up with Avatar to where you could stick this thing in the lobby of a movie theater where someone could actually go have an experience, right? An Avatar experience virtually, and, flying around and doing all that stuff, and then go see the movie. Like there's some really interesting ties you can do with media, and other things. So most likely not targeted at the direct consumer at first. It'll be more in the gyms and other applications where multiple people can use that same machine.
I think that's an awesome idea. I really love surfing. I grew up in Hawaii, but I hardly ever get to do it anymore because I live in Arizona. Not too many oceans here. But if I could duplicate that experience, I mean, I don't need to be in the ocean necessarily, right? If I could duplicate the sensory experience of it, that would be
Right.
amazing. I would do it every day, and it's incredible exercise. So I love the concept there. How, if you can speak about this, how far away are you guys from, having your MVP ready to launch wherever that might be?
I think we're really close. I mean, the machine has gotten tightened up over the last couple years. We've added some features, subtracted some features, and I think we've finally gotten to that sweet spot where the mechanisms and the structure and what it can do ties nicely with what we're seeing on the video side and the on the virtual world side. So I think we're there, and now it's just a matter of exposing it to people and seeing if can get some interest.
Amazing. Very cool. Well, good luck with that.
Thank you.
What have been a few of the most difficult technical challenges that the engineering team has had to solve, and how have you overcome those challenges?
Um, for Ethereal,
Yeah. Yeah.
so the challenge is always cost, right? So
Hmm.
there's a couple things, right? So anytime I think Ethereal and Exo, when you're dealing with humans, you have the variability of humans. So not only in size and shape and personalities, all those things come into play. And so how do you interface well with a human is a very challenging thing. So like on the exoskeleton side, it was like, well, how do you make a one size fits most exoskeleton that will be comfortable for all these different body types, sizes, like everything, right? So that's always a challenge. And even on the ethereal side, it's, you have this machine that you have to, well, we actually have hand grips that you hold on to. So it's easy. You're not like wrapping the machine around the user like an exoskeleton. It's more like I don't know, an external thing that you grab the end effectors, right? So your wrist or your hands are grabbing the grips to interface, and then there's the interface at the feet, and then we have to track everything. So we make a real avatar of you in that space. So when you're looking around, you actually see yourself. So how that interface works and making it as transparent as possible, right? And as natural as possible. That's the other challenge when working with humans is any discontinuity or anything that seems like not natural. Humans are they're very quick to
Hmm.
pick up on like a blip or something that doesn't feel right, right? Like you're very sensitive to things like, oh, that's kind of off. That feels off, or you feel like a little glitch. Like you notice those things. So everything has to be super transparent and super smooth. Otherwise, you'll ruin the experience, especially in the case of ethereal, where you're flying in this machine and flying around, and if like the arms were out of sync with what you're seeing, like it would scramble your brain. And you'd be like, "What's going on? Right? What's happening? I'm flapping down, but the wings are going up." So all those things have to be very well tightly coupled and transparent to the user to make that experience as real as possible.
Yeah, that makes sense.
Yeah.
Scott, Russ, it seems like you really enjoy the startup phase of a company. Is that fair to say?
Oh, absolutely. I love the mess of a startup. Like the early
That's a
days
good way to
where
put it.
it's like that early days where it's like you don't know exactly what the product should do. You don't know exactly who your customers are. You don't know what the pricing should be like. So you're figuring everything out and there's no right answer. And it's like this crazy multivariate problem that you're trying to wade through and figure out on the fly. I actually really enjoy that part of the process. And then once you kind of get through it and you start having a business that's like, oh, it's a commercial business and here's our sales and, here's what we need to do. There's a very clear product roadmap. There's a very clear production roadmap. Then it's less interesting because like, all that fun stuff is gone. And then it's more like turn the crank type of engineering,
Mm-hmm.
which is less of an interest to me. I really like trying to solve those really hard problems. Like as an engineer, you just like solving hard problems.
Yeah.
That I think is one of the most rewarding things to do. And so, yeah, the startup mess is where I like the early days of the startup mess is where I like to operate.
Have you ever found that to be a problem that intrinsically the most talented engineers are the ones who want to be solving the hard problems, which often come at the very beginning? And then when it's more like sustaining engineering, maybe not all, but some, or maybe a lot of the very talented engineers get bored and leave. And maybe what's left is the engineers who are like the B or the C level engineers. Have you experienced that or not so much?
Not so much. I think, like as a company, I think you can constantly reinvent yourself. Like at Exo, right? There's, you have your pivot. So we started as a military type of exoskeleton for load carriage. Then we pivoted to medical. Then as we're going through that, and that starts to become clearer and more defined and turning more into that turn the crank type of engineering, then it's like, okay, what else can we do? Right. And so then you switch gears and go after the industrial and construction space, right? And try to reinvent yourself
Mm,
there and go after new challenges and new spaces. So I think you can always challenge those types of engineers and companies. Like that's what you should be looking for is, okay, once you kind of have that product roadmap kind of defined for whatever line you were working on, it's like, okay, well, what's next, right? What should you be doing next with that group of engineers that just got through all that, where they don't really want to work on the sustaining part of it, right? And they're typically, those engineers aren't built the same, right? You have a different skill set, like sustaining engineers, manufacturing engineers, the people that live and breathe that, like they have a very awesome skill set and they love what they do in that space. And it's very different than some of these early engineers that are kind of trying to figure out these hard problems. And there's no real structure, right? They work really well in an unstructured environment. So you need both types, right? And then it's just a challenge for management to figure out how to keep everyone happy and keep them moving forward.
yeah, well said. Well, I'll take a very quick break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. And today we're speaking with Russ Angold. Russ, can you think of a major success and conversely a major fail that you have experienced in your career and kind of what you took away or learned from each of those situations?
Oh yeah, because there's definitely both, and they happen frequently. So I think the major success in the career was getting Bionics to a place where we were providing those exoskeletons to individuals that had lost that ability to walk. So there was nothing more rewarding than seeing someone that, at some point a doctor had told them, you're never going to walk again. And they come in and maybe they have their family or friends there and they get in that device and they get up and take their first steps. That was always a fantastic moment for me, right? Because you
Yeah.
could just see it, and then that someone along the line told them they're never going to walk again, and in that moment they're walking again, and that's just the first step in their recovery and their rehab. But it's kind of them like sticking their finger to whoever told them that was it for them. So that was always a very rewarding moment for me personally, seeing that. So I would put that in the category of successes for sure. In terms of failures, man, we happen all the time. And the one benefit we had, especially in the exoskeleton space, was we are. I guess we have this amazing sensor suit called a human that can give you real time feedback if something feels good or feels bad. And so when we were trying out ideas or concepts, we would try to prototype the roughest thing you could get, right? The lowest fidelity that you could get to actually try out a concept and strap it onto somebody to give you that, is this the right path or is this the wrong path? And we are fortunate, again, that humans are really good at discerning that. The worst answer was if you got a, no thumbs up, no thumbs down, but like, oh, you got to make the prototype better because we don't know which way this is going yet. But our method was to try to fail as fast as possible. Like, hey, we have a crazy idea. All right, go build it in the shop as quickly as you can. I don't care what it looks like. I don't care like if
Duct
it's
tape,
overweight,
super glue,
whatever. Yeah, whatever you can scrounge together, just go and test it. And it has to replicate whatever feature you're trying to accomplish, or function you're trying to accomplish. But build the ugliest, quickest thing you can and test that out, because it's much easier to fail like that versus designing for 6 months and then having a failure and looking back and like, wow, how did we get here? The other one I would say was talking to the customers. Like that was literally, like I said early on in the podcast, like not talking to my brother before stepping on to Exo. Had I talked to my brother before and showed him that video, I probably would have never gotten the exoskeleton space. So, maybe it's a blessing in disguise that I didn't show him the video. But again, I would say showing whatever technology you are, really understanding the customer and what they're wanting before you dive headlong into something is a very important part of this journey, right? Making sure you really understand what they want.
Do you have any tips on how to find the right people to show your product to and get feedback? Everyone's so busy these days, right? Like you send out some emails, it's hard to get a response. Any advice or tips on how to accomplish that process?
Yeah, what I would do, if you can find them, find whoever is the actual user of your product. So if you can find somebody within a company that's actually, or whoever's doing the task is going to benefit most from whatever your product or app or whatever you're selling, right? If you can find a group of individuals that are potential users and then give them your device, don't sell it to them, don't do anything, just, give it to them for a week or whatever. And then come back a week later. And if they don't want to give it back, you're onto something. If they're happy to give it, if you walk in and it's sitting in the corner and it looks like it's collecting dust and it hasn't been used, you kind of got your answer. So
yeah.
I'm all about, especially in the robotic space. It's really interesting because sometimes you'll have management or somebody who's really interested in automation or they want to add a robot to whatever process. And sometimes they're not the actual people that are going to be using it on a daily basis. And so sometimes you can get a false sense of opportunity because someone has an initiative to add a robot versus like the actual, like, is there a use case and a real value proposition for the business, right? And so making sure you kind of get through that. I think if you can get to the actual end users of whatever it is you're trying to sell, you can kind of cut through that layer and verify for sure that they really want it.
Yeah, for sure. Okay. Well, you started a few companies, or at least co-founded a few hardware companies now. Any advice that you'd give to engineers out there who are considering starting their own business, their own company to develop hardware products and devices?
Well, I think it's in the name, hardware. So it's definitely difficult, but I think we need more of it, right? I think the nice thing now, like when we started Exobionics early on, like it was really hard to find anything, any of the fundamental components that we needed: sensors, motors, batteries, controllers. Like everything was very expensive, or we had to invent our own, and it was very challenging. Now I think there's a ton of technology on the shelves that you have access to. So that's a huge win for the hardware space, right? Thanks to everybody else that's been developing these motors and sensors and batteries, you can leverage that. The other thing I would say is surround yourself with some mentors or a team just to bounce ideas off of, and someone to talk to as you're going through the process. Because they may have some ideas, they may have some scars on their back and some advice on how to avoid some of those pain points. So definitely talk to other people that are in the space and build up a little network that will definitely help you get through it. But yeah, take on the challenge. I think hard work's great because if you come up with a good idea in that space, it's typically easier to build a moat around than a typical software application.
Yeah, I'll second the recommendation to develop a group of mentors. One thing I didn't realize when I started this podcast is that inherently it was going to produce a group of really smart people that have been extraordinarily kind and generous over the years in giving me some advice. And I've been able to reach out to previous podcast guests and say, hey, I'm struggling with this thing. What would you do? And they'll actually respond and give me really terrific advice. So having mentors to turn to is so huge. All right. I've got, this question I don't ask all the time because it's kind of a weird question, but I think it's so interesting in like how it helps us understand the minds of different people. So what is the most scared you've ever been? And like, how did you handle the situation? What did you learn from it? And feel free to take that either from like a professional standpoint or a personal standpoint, however you want.
Yeah. Okay. So, let's see, the most scared I've ever been. I think in business, like early on at Exo, we were starting to grow. We had done a licensing agreement with Lockheed Martin, and we were hiring new engineers to come on board. And there was this moment in time where we had this mismatch between, the revenue and the money coming in versus the money that we were spending on employees. And so I was cutting personal checks to cover payroll.
Oh man.
And you're looking at the numbers and you're just like, oh man, like how soon till like I run out of money? Like,
that is terrifying.
Make it through this, right?
Yeah.
And you could see like, it was scary, but you knew there was an end in sight. So it wasn't going to last forever. You just had to make it through this little dip. But I remember like having like 3 young kids and a wife at home. I was like, oh my God, I'm spending all our money and we're going to run out of money. What are we going to do? So that was probably one of the more terrifying business things I've been a part of, where you weren't sure how you're going to make it. But, you had your employees and they didn't want to lose any of them. And you're like, oh. And so I don't think many of them knew at the time that we were doing that, but definitely got us through that pickle.
Wow, what a great story! Thanks for sharing that. I can empathize with how terrifying that must have been. Let's see. In your experience, what are one or two of the most common ways that engineering teams mess up product development?
I think we've talked a lot about it, just not understanding the customers. I think that's a big one. And the actual use case and the final need. I think that that's fundamental to really good product development is understanding that. The other one's just good communication between the teams, like having a good culture of open communication where, things are going to go well, things are going to go wrong, but as long as everyone's, rowing together and going forward and communicating both those successes and failures as they go through it, that's how you make a good product, right? And challenging each other, right? Like someone may have a good idea or a bad idea, and having somebody call them out on like, hey, why did you do this? What about this? And people being open to those other ideas. Like, I think the more flexible people are to other people's ideas inside that team, like you don't have one really loud voice, but everyone's kind of working together. That's where you really get to a good end result.
There's a wonderful book called Culture Code. Easily the best book I've ever read about developing cultures and safe environments for teams to work in. And the author argues that there are 3 pillars that lead to successful teams that work together really well. The first one is establishing safety. And he's referring to psychological safety, not physical.
Right.
Of course, physical safety is important as well, but
it's implied. Yeah,
especially when you have exoskeletons walking around, right?
Right.
So is establishing safety, sharing vulnerability, is the second one, which I think is pretty closely related to establishing safety. And then the third one is creating purpose for the group. Anything that you can think of that you and your leadership have done in the past specifically to encourage that like psychological safety within the team?
Yeah, I think, leading by example, just being vulnerable yourself, like, hey, like this might work or it might not. Like, here's an idea. And if somebody comes up with a better idea as a leader, like you can't have the ego to where you're like, oh, that'll never work, right? You're like, yeah, try it. Or like just being open to those other ideas and not having those egos get in the way, I think is very helpful. I think we had it a little bit easier at Exo just because our purpose and what we were building for was so impactful. Like everyone wanted to do a really good job. And so I think that helped, squash some of the egos, but they still showed up and you just managing that and making sure that, like you said, everyone felt the ability to voice their opinions and not have repercussions from other people. That's really important. So I think the best thing you can do is just leading by example yourself and then enforcing those rules as somebody comes out with a crazy idea or challenges someone's idea, supporting that process and helping it go through. And I think the more repetition you get every time that happens, the more comfortable people get.
I really like your comment about leading by example and being vulnerable as the leader. I think there's a lot of power in that. I have certainly been a part of groups where individuals opened up and shared something really personal about themselves. And I mean, really the definition of vulnerability, right? Kind of exposed themselves. Just here it is. This is who I am. And, very easily could have, been pointed fingers at or mocked or something, but they just opened up.
Sure.
And the funny thing is that you might think that, well, I'm admitting to this like horrible thing that I think about myself, and no one's going to like me once they find out. But it's totally the opposite, right? Once you expose that level of humanness within you, and people hear it, man, they just like there's almost this bond that gets created instantly. And all of a sudden other people are like, oh, well, yeah, me too, I guess, if we're being super honest about it. And like people just start working together and understanding each other. And there's this humanity that naturally occurs. It's pretty amazing.
Yeah, I'd agree with that for sure. Yep, definitely seen that happen.
All right. Well, let's see. Just, I think a couple more questions and we'll wrap up here. What's a tool that doesn't exist, but if it did, would allow engineering teams to work better, faster, smarter, and you can feel free to stray outside the realms of what is currently known to be physically possible?
Yeah. Let's see. If you could just wish something to be physical and real within like minutes to test something, I think that would help on a lot of the hardware prototyping stuff. There's always that delay between the CAD prototype and the design, even your FBA between getting that to like a physical testable prototype. Like today I'm waiting for parts to show up so I can test the durometer, so I can test the functionality of one small thing before I can actually have the final part ordered, which has like a 6-week lead time. So like I'm trying to speed this up as fast as possible, but I have to wait for these physical parts to test that actual physical interface and how it's going to react with this weird product. And it's a little bit of an unknown. So I have to test it physically. So anything I could do to like speed that process up would be very helpful in my mind. I don't know if we could do it digitally, if you could simulate some of these things digitally. I think it's just too hard right now, but that would save a lot of time in my world.
Yeah, for sure.
Yeah.
3D printing has helped in that area, certainly.
For sure. But not quite there, right? Like sometimes you just see weird thing. I think my master car is actually probably the best thing going for people. Like you can get parts pretty fast, and maybe you can't get exactly what you want, but you can get, a pretty good stand-in. Like that's what I'm doing today. I'm just waiting for those parts to show up so I can get my stand-in parts, do a test, and then move on to the real part.
Can you imagine engineering without McMaster?
No,
It'd be horrible.
no. And I don't know if you know, but people that live like in LA, you can get McMaster car parts the same day. I used to get them the same
I've
day.
heard that.
Yeah,
That's amazing.
it was amazing. That was a
Wow.
miracle tool. Yeah.
That's a good way to put it.
Yeah.
A miracle tool. Yeah. All right. Well, let's see. Specifically within the context of your role as an engineer, what is one thing that frustrates you and one thing that brings you joy?
Well, as an engineer, let's start backwards first. The joy is like when you get to the end of a really hard problem, and you succeed, right? When you finally get it finished, like that moment where, that idea you scratched out on a napkin and you've been toiling on for the last 6 months is finally somewhere and it's working and the customers are happy. Like that part is like very fulfilling when you see it working. So I really enjoy that part, right? When everything is finally done and is working. The frustration part comes in like picking really hard problems. Like, and I think I tend to pick really, really hard things to work on. I don't know why. To the
Glutton for punishment.
Yeah. And sometimes I look, I'm like, man, there's so many easier ways to like make some money, but I really enjoy, I don't know if I'm a masochist, but I really enjoy these really hard problems. That's like literally, it's like someone's like, oh, no one's been able to solve this in 20 years. And I'm like, sign me up. And then you're like, whoa. And then you get into it and it's really, really hard and it takes longer than you think. And that part's frustrating, but I think that makes that final moment at the end so much more rewarding when you finally do get it. And you're like, well, nobody else has been able to figure this out, but I just did. So that part's really rewarding, but yeah, it can be when you're in the trenches and you're slugging through it. Like I have a project right now I'm working on where I am at 99.99% accuracy on what I'm trying to detect. And this is for the ag space, which is amazing. And no one's been able to do this. Problem is I need to be 99.999% accurate. So I still have an order of magnitude to get better. Like it's already amazing, right? And like I should be jumping for this, but I still have one more order of magnitude to go before the detection levels where I need it. And so you're like, oh, it's super frustrating, but I think I have a path to finish that out. So those moments, right, are the frustrating ones. But once I finish that, then I'll be very happy.
Yeah, well, hopefully there's one of those joyous moments just over the horizon for you on this last order of magnitude.
Right.
All right. Well, Russ, thank you so much for spending some time with me today and just sharing a little bit about your background and some pro tips based on things that you've learned in the industry throughout your career. Anything else that we haven't talked about that you think we should hit on before we wrap things up?
No, I think we covered a lot today. Yeah, I guess the one thing is don't be afraid to take on those big challenges, right? Because they are rewarding when you solve them. And especially if you're thinking of doing things in the hardware space, you're going to have your ups and downs. And maybe that's your big takeaway is, especially in a startup and working on hardware, is celebrate the highs when you get wins, celebrate the wins, and then, just get through the losses because it's a roller coaster. And so don't wait to celebrate something. Like any win, celebrate it because you're going to need that energy to carry you through some of those low points.
Oh, that's great advice there. Thank you for that. All right. Well, Russ, how can people get a hold of you?
The easiest way is to look me up on LinkedIn, Russ Angold on LinkedIn. I should pop up. No problem.
Terrific. We'll put a link to your LinkedIn profile in the show notes as well. All right, Russ. Well, thank you again so much. I sure appreciate you spending some time with us today.
Absolutely. It was fun. Thank you.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, Visit us at teampipeline.us. Thanks for listening.